Hello students, welcome to Rino class. Topic magnetic field line. Take a bar magnet and a nail. Okay, and place the nail nearby the bar magnet. Like this way. You can observe that the nail is coming closer to the magnet. From that, we can say that the magnet can exert a force on other magnetic substance. Okay, if you take the nail little bit away from it, the attractive force is smaller. Okay, again you take the nail little bit away, the nail is not moving, so that is the nail experience the magnetic force is very smaller, that is we can neglect. From this we can say that the magnet will experience a force only in a particular region. That region we will call it as magnetic field. Okay, now we can define magnetic field. It is a region around a magnet in which the magnetic force will be experienced. Okay, in which region the magnetic field is experienced, that is the magnetic field. Okay, so the pictorial representation of a magnetic field is magnetic field line. Okay, so now we can define the magnetic field line. Okay, this is the definition. It is a closed continuous curve drawn in such a way that tangent at any point gives the magnetic field direction at that point. That means you consider this is a magnetic field line. If I need to find out the magnetic field at any point, that is this point, what you have to do? Draw a tangent. This tangent gives the magnetic field direction at that point. Okay, so this is about the magnetic field line. Now we will see what is the pattern of magnetic field line produced by a bar magnet. To understand that, we have to do an experiment. So, we will take a bar magnet and a cardboard. Place the cardboard over the bar magnet. Place the cardboard over the bar magnet. Okay, how we will get the diagram? I will show you. This is a cardboard. The magnet is placed like this. Okay, it is not over it. The cardboard is over the bar magnet. Okay, to understand that I am drawing this. Okay, spread some iron powders over the cardboard and make a small shake on the, like you just try to shake the cardboard. From that you can observe that the field lines, that is the iron powders, are arranged like this. Okay, this way the iron powders are arranged. That is, this is the pattern of the magnetic field line of a bar magnet. From this we can draw the pattern of the magnetic field line of a bar magnet. This is the north pole and this is the south pole. Okay, from the north pole the magnetic field line originates and end at the south pole. Okay, this is the magnetic field line produced by a bar magnet. Okay, now we will see the properties of bar magnet. Okay, properties of magnetic field line. Okay, the first property is the magnetic field line outside the bar magnet is from north to south. North to south you can observe here. And what about inside? Inside it is from south to north. South to north. And the magnetic field line is a continuous closed curve. That is the next property, the third property. What is meant by continuous closed curve? Continuous closed curve means the field lines originate from a point and it is to be circulating. That means you see this, the magnetic field line is originated from the north and end at the south. Again inside it is continuing like this. So this is a continuous close. There is no break in between also. Okay. So this is the magnetic field line. Okay, it is a continuous closed curve. In the electric field line is not a continuous closed curve. It is a continuous line, but it is not a closed curve. You may be observed like this. So, from the positive charge of the field line originate and end at the negative charge. It is not again coming back from the negative charge toward the positive charge. Okay, this is the electric field line. Okay, it is not a continuous closed curve. Okay, clear. Then the next property is the magnetic field line never intersect. Magnetic field line never intersect. Why? If the magnetic field line intersect at a point, that point two direction of magnetic field line will produce. That means you see this. This is a one magnetic field line, okay, and this is the another magnetic field line. These two are intersecting at this point. Okay, so based on the definition of the magnetic field line, tangent at any point gives the magnetic field direction. So I am drawing the tangent by considering this at this point. So I got the magnetic field is in this direction. Okay, by considering this field line, I am drawing a tangent. I will get the magnetic field is in this direction. That means in one point itself two directional magnetic field. That is not possible. So we can say that magnetic field line never intersect. Okay. Then the next property, okay, that is in a region the magnetic field is stronger. That region more number of field line are crossing per unit area. That means if I am going to take a small region here, this is a unit area in this region. Okay, I am going to take it as a unit area in this region 2. So from this you see this in the region 1 the magnetic field line passing through the unit area is more compared with the region 2. So I can say that in the region 1 the magnetic field is more strong. Okay, then this is about the properties of magnetic field line. Now we will see the magnetic field line behavior when the same poles repel and the opposite poles attract. That means you see this. I am taking the north pole of a one magnet and the south pole of another magnet. So these two poles attract each other. Okay. In this case, how the magnetic field line behaves? You see this, the magnetic field line originates from the north and end at the south, like this. Okay. This is the way the magnetic field line behaves. So this will attract. Okay. Next, I will take a north pole of one magnet and the north pole of the other magnet. This time these two will be repel each other. So the behavior of magnetic field line is like this. So in between there is a neutral point. Okay. This is the way the repulsion time the magnetic field line behaves. If to south pole, okay, this is the south pole of one magnet and the pole of another magnet. Okay, how the magnetic field line behaves, you see. In between there is a neutral point. Okay, clear? This way, when two south pole place closer, the magnetic field behave. Okay, this is about the magnetic field lines. Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.